Technology represents the powerful tools that the learner can use to facilitate his or her own learning process. The pre-service teacher technology competencies identify areas of proficiency for teachers to effectively use technology resources to create the conditions that optimize learning. Teachers need knowledge of the basic technology equipment operations and concepts, technology resources and tools for information literacy, and technology resources and tools for content areas. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 9th grade algebra class are learning about quadratic equations. The students have to complete a worksheet that will help them discover the factored form. The teacher demonstrates technology competency number 4, equipment operation, by designing a learning activity that teaches the students to use discipline-specific equipment. The students use TI-83 graphing calculators to find the relationship between the factored form of a quadratic equation and its graph. The teacher shows the students how to use specific features on the calculators.
You're using the zoom decimal window, correct? Do you know how to get the grid to appear on your calculator? So that you can sketch it better, the grid. You see on the worksheet there's dots on there? If you do, let's see, second zoom, you are looking at the format, and you're going to want to turn the grid on. So highlight grid on and hit enter. And now when you do any graphing, you will see those dots appear. Here's the original. Where's their graph at?
On top of it.
How do you know?
Because we checked it.
How do you check it?
Good trace.
You can hit the trace button. If you hit trace, I'm at the order pair 0, 0. Do you notice I'm on the first equation? If I hit the down arrow, I'm on the second equation, the one that they said it's equivalent to, and I'm still at 0, 0. That's one way of showing that they're the same. Another way of showing that they're same, how can you do it? Beth?
Make the line diagram.
Good. Do you remember how to do that?
Y equals.
Can all of you try this? Go to y equals. You can type in x to the third power minus x, and then type in what they said was the solution, which is correct. And Beth said that we can make the line look different. And to do that, we want to highlight this flashing backslash. And when I hit enter, it changes to a bold backslash. And that's what you want to do. You just want to hit enter once. And when you graph it, it should show the original. And then it shows, did you see that? It put the second one on top of it in the bold. I just want to show you one other feature. Go to y equals. If you hit enter again, this is going to do some inequalities for you. So instead of an equal sign, if we had a greater than or less than symbol, we could do some shading. If you hit enter again, it does shading below the graph. If you hit enter again, you see this little line with like a 0 flashing. When you do that and you hit graph, it draws the first one, and then the second equation, it draws it, and it draws the path of it. And you can see that it's tracing the path. That's kind of neat, isn't it?
The teacher uses the graphing calculator with a TI view screen and overhead projector to help the students interpret graphs. She helps the students enter data into lists on the calculator so they can graph the solution to a real-world application problem.
Who can tell me how I would enter data into the list? Who remembers how to do that? How do we? Stat. We're entering statistics. Good. Hit the stat button. Can everybody find it? It's in the third row in the third column. When you hit stat, this menu should appear. And the first thing we want to do is edit. So hit enter. Okay, there's our list. We can do up to 3 lists. We can actually do more. This calculator allows me to do 6 different lists of values. In L1, let's go ahead and type 0 through 8 and then stop, because I'm going to show you something new when we get to L2.
Then she uses the calculator to graph the data. The view screen lets the whole class see and interpret the graph of their solution.
What is the real-world interpretation right now of x being 0, scroll down there to the left, and y being, nope, I can't, that's the best I can get. Who can tell me what that means right there? What's the interpretation of that? Ryan? The area is. That's where you'd have the smallest area. Okay, right there.
The teacher extends the students' knowledge by having them do an experiment. The students will use motion sensors called calculator-based rangers to collect and interpret data. The teacher gives the students step-by-step instructions on how to connect the motion sensors to the calculators.
You have a adapter, a link, that you want to press into the bottom of your calculator. If it's out just the slightest bit, you're not going to get a good connection and the program won't load for you. You have to make sure that that's pushed in all the way. On the calculator, in gold, do you see the word link?
Yes.
It's under the X button. It's in the third row, second column. You're going to need to push second link. And the calculator responds by saying, do you want to send data from the calculator to the CBR, or do you want the CBR to send you information and you want to receive? So you're going to arrow to the right to receive, and then you hit enter. So again, that key sequence was second link, arrow to the right, and hit enter. Now it's waiting. So you pick up the CBR and you open it up. And remember, this is a motion detector. And inside here, we see 3 buttons. And they correspond to 3 different types of graphing calculators. We're using the TI-83, so you're going to want to push the 8283 button. When you push that, it is transferring the data, and it should beep like that, and it should tell you that it's done. Okay. Now, to know if you have it or not, I have to hit second mode to quit. When I go to program, that should be the only program that's listed in your calculator. It's the Ranger program. Okay. Now when I hit enter, and I hit enter again, I'm able to use the motion sensor. And so I just unplugged it. I'm going to need to plug it back in. And you open up the motion sensor head, and you point it at the target. And then, depending on what the experiment is, will depend on what buttons you hit next. So let me talk to you next about what the experiment is.
Before the students start working in groups to gather real data for their activity, the teacher gives them a concrete example of how to use the motion sensors in conjunction with the calculators.
It says to press enter to start this. And I'm going to do a setup sample, so I want to press enter again. We are going to leave this as is. We're going to graph in real time for 15 seconds. We're going to display distance on the y-axis, or it's going to start when I push the enter key. The smoothing feature is whether or not I want to connect the points smoothly. There's different varying degrees of smoothness. We're going to leave that alone, and the units will be in meters. So what you'll want to do is arrow up 1, so it says start now, and then I will press enter, and then it'll give me one more direction. It'll say point the CBR at the target, and I have it pointing at him, and then I need to press enter to get the graph to go. You ready? When you see the green light flickering, it's starting. Is he doing it correctly? What's the graph doing right now?
Move back. Move your hand closer.
Do what?
There you go.
Okay, so did he graph what we needed to graph? This looked like the length versus width data.
Very inaccurate stuff.
Throughout the lesson, the teacher used appropriate terms to talk about the calculators and calculator-based rangers the students have used. This demonstrates technology competency number 2, terminology.